All right, so we're going to start with some examples of just inequalities to review what we did the first day. So for the first example, we're going to solve for x. So act like the inequality is an equal sign. So the first thing you'd have to do is subtract 3. And then divide by 2. And you should get x is less than 1. So it's an open circle. You can pick anywhere. Open circle at 1, and it's x is less than. So we want everything to the left of 1. For number 2, you would add the 1 over. Divide by -4. And then remember, whenever you divide or multiply by a negative, you have to flip the sign. So since I divided by -4, I now have to flip the sign. And then 8 divided by -4 is -2. So it is a closed circle, wherever you want to put -2. And x is greater than. So greater than would be to the right on number line. And for the one on your own, you should add 2. Divide by -5. Should have gotten x was less than -1. You had to flip the sign. Open circle at -1, and x is less than is to the left. So this is a review of what we've done before. All right, so we're going to do just a few examples of setting things up with word problems. So it says, if the difference of a number and 3 is greater than or equal to 5. So difference means subtraction. And of a number, so this is subtraction for sure. And of a number, we don't know that number, so that's x. You know, this is 3, obviously. Greater than or equal to, and then 5. So the subtraction of a number that we don't know, x, and 3 has to be greater than or equal to 5. So the difference of a number and 3 has to be greater than or equal to 5. So they said, what's the possible values of the number? So if we go to solve this, x is greater than or equal to 8. Any number bigger than 8. So any number greater than or equal to 8. So 10, 15, 17, 20, whatever you want to do, any number greater than or equal to 8. So the one on your own, sum means plus. Twice a number. So twice a number means you're doubling a number. We don't know what the number is, just 2 times a number. And 1, when 1 is less than, so that's the less than symbol, 9. So the sum of 2 times a number, sum is plus, and 1 has to be less than 9. So when you go to solve this one, you get x is less than 4. So any number less than 4. Any number less than 4 would work. Down here, we're talking about possible solutions. So possible solution means it falls in the shaded region. So what I'm going to do is solve. And then you can figure out if it's a possible solution. So if I go to solve this, I get x is greater than -5/2. So is -4 greater than -5/2 on a number line? -5/2 is 2.5, -2.5? No, so this would be no. -4 is not greater than -5/2. So it would not be in the shaded region. For this one, if I solved 3, x is less than or equal to 3. So is 3 in this shaded region? Yes, because this is including 3. So solutions are just where you shade. Anything that can be shaded. All right, so let's get to compound inequalities. So flip it over. So compound inequality, here's two examples up here. They're and statements or statements. So they're basically, you're solving two inequalities at once and putting them on one number line. So for the first example, solve both of them like you normally would. So add 7. So you get x is less than 9. And x is less than 4. So I don't care where you put them. Just make sure 9 is greater than 4. So make sure you put them systematically where they're supposed to be. So open circle at 9, open circle at 4. And then you want to shade where it overlaps. So x is less than 9. So I'm going to do my arrows. X is less than 9. And x is less than 4. So really for this one, the shading is overlapping down here. So it's less than 9 and less than 4. Your shading overlaps to the left. Remember, with and statements, it's just where it overlaps. So you're only shading one part. The or is when you shade in different parts. And is just one part you're shading. So for example 2, you should get x is greater than or equal to 0 and x is less than or equal to -2. So close circle at -2, close circle at 0. X is greater than 0. And x is less than -2. So if you notice for this one, there's no part where it overlaps. So these are the two special solutions that we were talking about yesterday. So here there's nowhere where it overlaps. So this would be no solution because there's no overlapping. So there would be no shading. All right, so for number 3, solve it. X is less than or equal to 5/13, or 13 over 5, sorry, 13 over 5. Or x is greater than or equal to 4. So we have a closed circle at 13/5, and we have a closed circle at 4. X is less than 13/5, or x is greater than 4. So or, it doesn't matter, you just graph both of them. It's this or that. For example 4, closed circle at 1, closed circle at 3, x is less than 1, or x is greater than 3. Pretty simple. 5 and 6, you don't have a number line, just sketch one. So for 5 and 6, if you notice, there's two inequalities mashed together as one. So what we're going to do is you have whatever you want to get x alone in the middle. Whatever you're undoing in the middle, you have to do to every single side. So for instance, to get x alone, I would have to subtract 1 first. But then that means I have to subtract 1 from all the sides. And then I would divide by 5, so then I have to divide all the sides by 5.